Welcome back to another journey into the unknown. Last time, we explored nothingness, the speed of light, and the possibility of vacuum decay. Today, we'll take on an even stranger topic: time itself. We live inside time. We measure it with clocks, we feel it passing, we fear losing it. But when scientists look closer, time behaves in ways that seem impossible. In this episode, we'll explore three mysteries. First, why does time only move forward? Second, how could the universe end in the so-called heat death when time itself may lose its meaning? And third, are time travel and paradoxes possible or forever forbidden? Three questions, three paradoxes of time. Let's begin. Part 1. Why does time only move forward? Every day, we watch time moving in one direction, forward. You get older, not younger. Memories form about the past, not the future. But why? Why doesn't time flow backwards? The answer begins with the arrow of time. In physics, the laws that describe motion are mostly reversible. If you filmed two billiard balls colliding, you could play the video backward and it would still look possible. So why does reality prefer one direction? The key is entropy. Entropy is a measure of disorder. When you drop a glass, it shatters into pieces. But the reverse, broken pieces leaping back into a perfect glass, never happens. That's because the universe naturally moves toward states with more disorder. Time's arrow is tied to entropy. We remember the past because it was more ordered. We move into the future because disorder increases. You might ask, but couldn't entropy decrease somewhere? Yes, in small systems it can fluctuate. But for the universe as a whole, the overwhelming trend is toward more chaos. That's why time has a direction. So time itself may be nothing more than a shadow cast by entropy, a record of increasing disorder written into reality. But what happens when disorder reaches its maximum? That takes us to our second paradox. The heat death of the universe. Imagine fast-forwarding billions, trillions, even quadrillions of years. Stars have burned out. Black holes have evaporated. Matter itself may have decayed. What is left? A thin, cold sea of particles and radiation, spread evenly across an endless cosmos. No energy differences, no heat flowing, no work being done. This is the heat death of the universe. In this state, entropy has reached its maximum. Every process that could increase disorder has already happened. So what does time mean in a heat-dead universe? If nothing changes, then time itself may lose its meaning. Time is defined by change, by events, by differences. Without them, the universe may still exist, but it would be frozen in a meaningless eternity. It's a haunting thought, a cosmos not with a fiery explosion at the end, but with a slow fading into silence. Some scientists argue there could be other endings, like a big crunch or big rip, but the heat death remains the most widely accepted fate. So time's arrow, which points forward now, may eventually point into a future where there is no arrow at all. But before that distant end, could time ever bend back on itself? Could we travel into the past or the future? Let's explore the final paradox. Part 3. Time travel and paradoxes. The idea of time travel has fascinated humans for centuries, but is it possible? First, the easy part. Traveling to the future is real. According to relativity, time runs differently for observers moving at different speeds. An astronaut traveling near the speed of light would age slower than people on Earth. This is called time dilation, and it's been proven with experiments on fast-moving particles and even atomic clocks. But what about the past? That's where things get messy. If you could travel back in time, you could create paradoxes. The most famous is the grandfather paradox. If you went back and prevented your grandparents from meeting, you would never be born. But if you were never born, you couldn't go back in the first place. Some scientists have suggested loopholes. In quantum physics, maybe every action creates a new timeline. In that case, if you go back and change the past, you don't erase your timeline. You simply branch into another one. Others argue that the laws of physics simply forbid backward time travel. Wormholes, cosmic strings, and closed time-like curves exist in theory, but they may be impossible to create in practice. So the dream of visiting the past might forever stay science fiction. But the dream itself tells us something. Time is not just a background. It's a player in the story of the universe. And it may not be as rigid as we think. Outro. So today we explored three paradoxes of time. Why does it only move forward? Because entropy gives it an arrow. How could it end? In the silent eternity of heat death. And can we travel through it? Into the future? Yes. Into the past? Probably not. Time is the stage of our existence, but it is also a mystery we have only begun to understand. Perhaps one day, far in the future, humanity will learn to bend time, or perhaps time will always bend us. Either way, the questions remain, and maybe that is what keeps time itself meaningful.